things here, okay? On Trooper Tide Tuesday, the 5th of January, of course, I'm wearing Trooper Ties on my Trooper Tide Tuesday, you guys know. Okay? The Darth Vaders are the black ones, and then surrounded by a bunch of stormtroopers. Yes. Yeah, you'll have to get a close-up view later, okay? As to BBA, you guys will be able to solve systems by graphing, section 5.1. So we're going to start chapter 5 today. You might be wondering, Mr. Costa, what's a system? Okay, well, we first need to answer that question. But before we even do that, I'm going to write my name. Okay, Mayamo Senor Costa. So if you haven't written your name yet on this, go ahead and do that now. Nope, I am a guy. Hence, Mr. Okay. But what is a system of equations? Okay, well, a system of equations is going to be a set of two or more linear equations containing two or more variables.
I believe correct.
Can it just be two?
Nope. Because it could be 3 or 4 or 5 or 6 or 7 or continue on. Now, linear. What word is inside a linear? Line. So these are equations that make straight lines. You guys remember doing these right before break? We graphed the lines. We made equations for these lines. Okay. Nope. So they were equations that made straight lines. Okay. So a system is just going to take two or more. We're just going to work with two though in here. It's going to take two of these linear equations and put them together. Okay. We're going to say they're linked together. Okay. Not Zelda together, but linked together. Okay. That was just because of the sure dash there. Okay. Also, I also beat Link's Awakening on the Switch. Super good. Never played Link's Awakening before that, so I was really happy they remastered it. It is good. I really liked it.
Are we talking about Nintendo games now?
Always, dude. Okay. So linear systems of linear equations, they're used to represent situations and solve problems related to consumer economics, finance, and geometry. So these have a lot of real world applications, especially in the realm of business. Okay, so a lot of applications here for business as well as some other things. But really, business is a primary application of these. Now, I said that it contains two or more variables. Variables, reminder, are like X, Y, Z, A, B. Okay, smiley face, star if you want. Okay, most commonly, our variables for these are going to be x and y, just like in our equations, how we had x and y. Now, we have three different methods we're going to learn to solve these systems. Okay, we're going to start today with solving by graphing. Hence, it says solving by graphing, and our learning target is solving by graphing. Okay, and we're going to learn a couple more in the coming sections as well. So, what do we mean by solving it? Okay, well, if two lines are graphed. Okay, we have two lines. They're always going to meet at one point. Unless they're parallel or the same line. What do you know about parallel lines?
That they never touch.
They never touch, right? And what do we know about their slope?
0.
They're equal.
They're the same slope, okay? So the parallel lines never touch. So they're not going to touch at one point because they never touch, okay? And if they're the same line, then they're just going to overlap each other. We'll talk about that more and more later. So the point where the two lines meet, okay, because we're talking about how almost always they're going to meet at one point. So where they meet, we call it the intersection. Where else have you guys seen the word intersection before? Streets, right? With cars and driving, okay? So two streets, how many times do the same two streets intersect? Like, think about that for a second, okay? Like, if you're driving down the street, are you going to cross the same street multiple times?
Yes.
No, two streets are only going to intersect one time, okay? So two streets are only going to intersect one time. Same idea. Two lines are going to intersect one time unless the streets are parallel. Then they're not going to intersect, okay? So we write this intersection as an ordered pair, x, comma, y, because it's on the graph. So we're going to say, it intersects at 4, 2. Or -3, 5, okay? Just making up random points here. Questions on any of this so far? Alrighty, so we're going to outline some steps here if everyone's good. Okay, so we have some nice detailed steps on how to solve these, okay? So if you ever forget, wait, how do I do this? Okay, we have step by step how to go through it. Our first step is to put both equations in the slope-intercept form if necessary. Can we get a refresh on what slope-intercept form is? Okay, y equals mx plus b. Lincoln was slowly but surely getting there, at least I hope surely. And then Ash going ahead and helped us out there, okay? So thank you to the two of you. Y equals mx plus b is our slope-intercept form, where our slope is our m, our b is our y-intercept, okay? And y and x are just y and x. Now, if we look over here, we've seen this brace before on this example, haven't we? Okay, you guys loved doing these braces, didn't you? With all the set notation. It was like, oh, that was a really bad one. It was just like x such that x is equal to blah, 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 blah. We're not doing that right now. Okay? We're not doing that. Take a sigh of relief. Okay? Take a breath. Okay? We're not doing that. Okay? We're not doing that in this chapter. Okay? How about that? Okay? Okay. So this right here. All right. By dropping out, Mr. Kossel. So this brace right here, it's just showing these two equations are in a system together. So it's just saying they're not completely separate. Even though they're different equations, they're paired together in a system. That's all the brace means here, okay? It's just saying we're putting these together in a system, okay? So our step 2 after we put them in slope-intercept form is to graph the first equation. It says use a ruler to draw a line. Okay, we'll go over that in a second. Then graph the second equation, doing the same, and then graphing and then writing the point where they meet or intersect, and that is the solution. Okay, so these rulers, okay?
It's broken.
The rulers, okay, are just to be used as a straight edge, okay? They're not a toy. Don't hit people. Don't hit things with them right now. Don't put them on your pencil and spin them around, okay? Okay?
Bro, this was the best.
Yeah, don't. Hey. So the thing I just said not to do, okay, don't.
I was showing a demonstration on
Oh, thanks. I didn't need it. Okay, everyone knew it. Okay, everyone knew what not to do. Don't do it. Okay. You're not Stop.
I'm trying to balance it.
Okay, you're not Thanos. It's not perfectly balanced as all things should be, okay? So guys, it's just a straight edge, okay? You guys can use anything as a straight edge that is straight. So you guys can use like a notebook, a binder, a phone, you name it, okay? Just don't use your hand and don't play with the rulers.
It can only go so far because this quits twisting.
Don't play with the rulers. That's not a reason to play with it. Phoenix, actually stop. Okay. So, we're going to go ahead and go through this here, okay? Put the equation in the slope-intercept form if necessary. On this first problem, are these already in slope-intercept form?
Yes.
Yeah, that's handy. The y is by itself. Boop. First step is done. Second step, graph the first equation. What two things from this equation do we need to graph it?
2 and 1.
-1.
The m and the b, what's the m?
-2.
-2. And what's the b?
-1.
-1. Now the m being the slope, we call that -2. -2 over what?
-1.
Over 1. Now which one of those do we start with? Please excuse yourself.
Excuse me. Okay.
We begin with b, the -1. So we're going to go where -1? Down. Very good.
And then over -2.
Not quite yet. So we went, the b was -1. Now we use the slope to make more points. So -2 over 1. Slope is what over what? Rise over run. So where are we going to go to?
Down.
Down. Where are we going to go 1?
1.
The right. This is a negative slope, so it should look like it's going downhill. Does it? Good. It should look like it's going downhill, okay? Now we could also go up 2 and left 1. So now what you would do is you would use your ruler, okay, and look up at the board right now, okay? And you would take your straight edge, your ruler, your binder, your notebook, your phone, you name it, and line it up on those 3 points and draw a straight line going through it. Now what you want to do is you want to have the line going past where it starts by a lot. You basically want it covering just about the whole graph, okay? Perfect. You can't honestly draw the line too far, unless you mess up another problem, I suppose. But you really can't draw the problem too far, okay?
I did it.
Any questions on graphing this first line?
I'm hungry.
Okay, now hi Hungry, I'm Mr. Carlson, nice to meet you, okay? Now, have we done this before? Have we done that part of this before? We've graphed the line, okay? So that's step 2, done. Let's look at step 3. Graph the second equation using a ruler to draw the line. So what's the m in the second equation?
1.
1. There's secretly a 1 with the x. And 1 over what? 1. What's the b? 5. Now, which one of those do we start with? B again with b. So where do I go 5?
Up.
Up. Now, where do I go with the slope?
Over 1.
Up 1, over 1. Which direction?
Over. Right.
The right. Does this look like it's going uphill? Yeah, and it should. Okay? Or I can go down 1, left 1. And I can use my ruler to keep extending this line as well.
It's not parallel. It's perpendicular.
They're not perpendicular, actually.
That's half.
But they do intersect. Now, can we tell where they intersect?
Yes. No.
Yeah, where do they intersect?
At the 3.
I don't have exactly.
Okay, how do we say this coordinate? What? Ooh, not quite. -2, comma 3. So our solution is -2, 3. It's that point where they intersect or touch. -2, 2 to the left. +3, 3 up. X, y, it's alphabetical. So -2, 3 is our solution. Now, can anyone tell me after we did one of these why we might want to use a ruler or a straight edge to draw these lines? Mally.
So you have the exact spot.
Yeah, so you have the exact spot. Because if you were off by even a little bit on one of your lines, would that affect your answer?
Maybe.
It totally could, okay? So you want to be very careful here, okay? So now check, okay? Well, how have we checked things in the past?
You reverse it.
Okay, yeah, you plug it in and reverse it really, okay? You see if it worked, okay? Now, do I ever, Lincoln, please stop. Do I ever make you check your work?
No.
No, I always present it as an option though, right? Okay, so we're going to do the same thing here. I'm going to present it as an option, but I'm not going to say, hey, you have to do this every single time, okay? But you can. And it's a good way to know that I get this right.
Why is the check there so that we have to?
No, it's so that I can show you how. You can write down how you do it, and so that way you can know if you want to do that. You don't have to, but you always can, and you know instantly if you got it right or wrong. Okay, so let's try this out here. So to check it, what has to happen is this point has to work in both equations. And if we look at this top equation here, okay, we have y equals -2x minus 1. We'll have to approach these one at a time.
Yes.
Now we see both a y and an x. Well, which one of y or x do we think the -2 is going to be?
Why?
The x, because it's in the x spot of the coordinate. Which one is 3 going to be then? The y, because it's in the x spot of the coordinate. So when you plug this in, it's going to look like 3 equals -2 times -2. Evan, please stop. Minus 1. So I rewrote this equation, the top equation, the first one that I circled in red. And I took out the y, I substituted it for the 3, which is in the y spot. And I have it equal to -2 times x, so -2 times -2 minus 1. So I just took the first equation, substituted out the x and the y for the point. Questions on that? Okay, and we put equals because we're checking to see if this works. So now, 3 equals, what's -2 times -2? 4, positive 4, minus 1. Does 3 equal 4 minus 1?
No.
No.
Yeah, it does. 4 minus 1 is 3, okay? So this one checks out.
That actually is 1 minus 4 equals 3.
No, it's not.
If you read it this way.
Yeah, but we are in America, not reading Japanese manga.
What?
Excuse me. So we're not going to read it the reverse direction of what we're used to.
But it is reversed.
Correct.
So you read it.
Okay, anyway, so then we plug it into the bottom equation as well. So we plugged it in the first equation, but we have to see if it works in both, because it has to be a solution to the system. So we have 3 equals -2 plus 5. We take the bottom equation, replace the y with the y from the point. We replace the x with the x from the point, everything else stays the same. Questions on how I got that so far? Okay, now what is -2 plus 5, Eben?
-2 plus 5.
Yep.
It's 3.
It is 3. So
You
does
wrote
3
it down before I said
does
it.
3 equal 3?
Yeah.
Yeah, it does. So does this work for both equations?
No.
Yeah, so we got it right. Okay, Eben, stop grinding that on the desk. Okay.
I don't like grinding.
Okay. Anyway, any questions on this one? All right, so just to recap, not no cap, but to recap what we did, okay, we had him put both equations in the slope-intercept form because that's easier for graphing. Okay, thankfully, excuse me, this time we didn't have to. The second one, we graphed the first equation. Third step, we graph the second equation. Then we say where they intersect. Checking is optional, but you always can do it. Any questions before we move on to the next example? All right, so on this next example, we have our system of equations again. We're going to follow these same 4 steps. Now this one, are they in slope-intercept form this time?
No.
That's a bummer. Darn it. Okay, which means we have to get them in slope-intercept form first. Okay, so we have to take this first equation. I'm just going to rewrite it so I have room. Negative x plus 3y equals negative 9. I'm just going to rewrite it so that way it's fresh. I know what I'm working with. So now we have to get y by itself to get this in slope-intercept form. So we have a negative x plus 3 times y. So which one of those are we going to get rid of first? The negative x or the 3?
Negative x.
The negative x. How do we get rid of the negative x?
Add negative x.
Add a normal x. Add a positive x. So negative x plus x is?
1. 0.
0. It's gone.
5.
3y equals... Do we know what negative 9 plus x is? Can we... No, they're not like terms.
Negative 9 plus x.
But we call it negative 9 plus x. But actually, which one do we want first? The negative 9 or the x? We want the x first, right? Why do we want the x first?
Because that y equals mx plus b.
Because it's y equals mx plus b. So we want the x to come first. Very good, very good. I love that.
FX.
Now, yes, fx does have the movies, okay? So, is y by itself yet?
No.
Not quite, okay? So what do we have to do before y is by itself?
Divide the 3 on everything.
Divide absolutely everything by 3. Very good. So what's 3y divided by 3?
Guess what?
Y.
Just y. Now, do we know x divided by 3?
No.
No, can we write x over 3 though?
Yes.
Cool beans. What's negative 9 divided by 3?
Go, Mom.
Negative 3. Karen Kossel is not negative 3. Just so we're clear.
Karen.
Yes, but she's not like the literal Karen with the memes, which is good.
I mean, she could be.
She doesn't want to.
Is she like a nice kid?
No, she doesn't have like the classic like Karen haircut and like doesn't always ask to talk to the manager and all that stuff. So-
Manager.
So yeah. Anyway, so now the first equation is in slope-intercept form, correct?
Yeah.
Okay, so now we need to do the same with the second equation. Now, I don't really have a lot of room over here, do I? It'd probably get pretty sloppy. So here's what I'm going to do.
Delete it.
I'm going to write it up here.
We don't have that option, Evan. Or Evan.
So,
Actually, I'm just gonna call you Evan from now
oh, okay, cool. I'm just going to write it up there where I have some room. So how do I get y by itself in this top equation, or in the bottom equation that I wrote up here in the green?
Man, we should do this.
2x by 2.
Not dividing x, but we subtract the 2x. Let's move the x away from the y. Yeah, I heard a few people say that. What's 2x minus itself?
Negative
0.
0. Yeah, if we but on the other side, we're going to have negative 2x plus 4, right? Heard some people starting to say that a little early. So is y by itself now?
Yeah.
Yeah, how nice is that? Okay.
It's pretty nice.
Yeah, that was one less step than before. It's pretty neat too. Okay, so on this first equation, so that now that we put these both in slope-intercept form, graph the first equation. What's the m for the first equation? What's the b? Evan, please stop.
Ouch.
So what's the m for the first equation?
1 over 3.
1 over 3. Very good. There's secretly a 1 over 3.
I said 0.
Oh,
Then you
whoops.
said very good.
Oh, my bad. I misheard you then. Okay. Appreciate the honesty there, though, okay? There's secretly a 1 with the x in front of it, so it's actually 1 over 3. What's the b here?
I would have never guessed this ruler was made.
Guess what? It's
Negative 3. So which one of those do we start with?
negative 3.
Negative 3. So I'm going negative 3 down. Okay, and the 1 over 3, how am I using that?
You rise
Rise 1 over 3.
Rise 1, run 3 to the right. And you can also go down 1, 3 to the left. And once again, you'd want to use a ruler there. Or if you really want, guys, you can make more points. Okay, you can count and say, oh, I'm going to make more points. I went too far on my first one.
I got really bad drawing skills.
Why are your drawing skills angry?
I said bad, not bad.
Oh, my bad. Alrighty, so the second equation, what's the slope of the second equation?
Guess what?
What?
2/1.
Negative 2/1, almost.
Oh,
What's the B?
4.
4. Which one of those do we start with?
Actually.
Which one do we start with? The 4. The begin with B. And I go where 2 and where 1?
Down 2/1.
Down 2/1, which direction? Left or right?
Left. Right.
The right. It's negative slope. It looks like it's going downhill. And I could also go up 2, left 1. And if I wanted to, I could keep making dots here as well.
Wait, what makes it a negative or a positive?
Whether the fraction is negative or positive.
Oh,
Yep. Thank you for asking that.
I thought it was the integer part, or not the where you start at. Like in positive form.
Oh, gotcha. Yeah, that part does not impact it. Lunch is at 12:15, and it is 12:13 right now, so we're pretty close. Okay. So where's the intersection of these 2 points? What's our solution here? Nope, they intersect. What's the solution to this?
Perpendicular.
3.5.
3 comma negative 2. Very good, Hayden. Very good. 3 comma negative 2 is our solution. So it's 3 to the right, negative 2 down. Okay. If you end up getting something off there, I would just double check your work. Okay. On the first graph, the purple one we did, make sure you're going up 1, right 3. Okay. And on the other graph, make sure we're going down 2, right 1. Okay. Any questions on that? Okay. Now, once again, do we have to check our work all the time? No, but I give you the option. Sarah, please put that away. Thank you. Okay, I give you that option to check your work there, okay? Now, on the next couple of problems, we're actually basically just going to check. That's basically all we're going to do, okay? So let's look at this. So here, we're asking, tell whether the ordered pair is the solution of the given system. We're given this system of equations, and we're trying to say, does this ordered pair work, okay? So before we were given the system, we found the ordered pair, and then you could check to see if it worked.
Oh, so we're plugging in the 4 and the 1?
Yep, you're plugging in the 4 and 1. You're basically just doing the check part from the end, is really all you're doing. And there's some steps here to help you if you want them. Saying you plug it in for the first equation, you plug it into the second equation. If it works in both, it works. It's a solution. If it doesn't, then it doesn't, okay? We're going to work on this more after lunch, but let's just go ahead and write out the first one, okay? The 4 is going to be the x, the 1 is going to be the y. So this first equation is going to be 4 plus 2 times 1 equals 6. And we're going to work on that more after lunch here. So you guys can go ahead and put your pencils down and get ready here to go to lunch when the bell rings. So before we left for lunch, guys, we said, okay, well, let's plug in the 4 for the x, the 1 for the y, and plug in the top equation. We're saying, does it work? And if it works in both equations, we're trying this first one, top one right now. If it works in both equations, then yes, it's a solution. If not, then no, it's not. So what is 2 times 1?
Guess what?
My Karen calls is not 2 either, okay? 4 plus 2. Does 4 plus 2 equal 6?
Yeah. Oh, wait.
You're doing times. Okay, 4 plus 2 does equal 6, though. So now let's check the second equation. 4 minus, spoiler alert, 1 equals 3. What is 4 minus 1?
Guess what?
3. So 3 equals 3. So does this work in both equations? So 4 comma 1 is the solution. You can just put this. Yes is your answer. Tell whether it's a solution. Yes, it is a solution. Here is our work to prove it. Okay? Classic theme song. So, please, Evan, thank you. Okay? Okay, we talked about that earlier. Okay, but let's not do that. Okay? So, number 2, I want you guys to do the same thing, but with that point, with those equations. I want you to try it. When you have it or have questions, raise your hand, okay?
Wait, did we say yes?
Sure. So, as I looked around, though, I saw a lot of really good things on this one, so hats off to you guys on that. Okay? So, as we plug this one in, 2 minus 2 times negative 1 equals 4. We're plugging this in top one, okay? So negative 2 times negative 1 is a positive 2. So 2 plus 2. Does 2 plus 2 equal 4, guys?
Yes, sir.
You betcha. 7 days of the week. Bless you and bless the rains down in Africa, lest we
You didn't
forget.
do it right. I'm just
Okay.
joking.
So let's plug it in the second equation. Just because it works in the first, does it automatically mean it's a solution?
Yeah.
No, we have to check both, and here is why. 3 times 2 plus a negative 1 equals 6 as I run out of room. 3 times 2 is 6. Does 6 plus negative 1 equal 6?
Maybe.
No. It'd be 5, not 6. So is this a solution? No. Our answer is no. This work above proves that. Any questions on that?
Gotta expel him.
Okay. So let's go ahead and continue on to the next page here. We only have a couple more examples left, okay?
And then we're done with notes?
Then we're going to do a very, very, very quick one on this foldable I'll give you that'll be helpful moving forward into the chapter, okay?
Let's go.
Well, these are going to go by pretty darn quickly, I do think, okay? So if two lines are parallel, they have no solutions because they never cross. There's no solution because they never cross, and that's why we don't play with rulers, okay? So parallel lines don't touch, do they?
No.
Now earlier, the solution is where two lines touched or intersected, right?
Yep.
So if they don't intersect, can they have a solution?
No.
No, that's why there's no solution. Okay? If two lines are, get ready for this fancy word, guys,
Perpendicular.
coinciding. Coinciding. I don't have any kids. Okay? Coinciding, which is a big fancy word, meaning they are the same line. Coinciding is a big fancy word, which really just means they are the same line.
That's cap.
Same line in parentheses.
Yep. Just a little explanation of it. So if they're coinciding, okay, they have infinitely many solutions. Because if they're the same line, then how many times do they touch?
0 once.
All the time. Because if they're the same line, then they touch all the time. So they have infinitely many solutions. Ah!
You're right, Phil.
It's a close rhyme.
You're right, Phil.
Oh, thank you. Alrighty.
Potter.
You're right. What?
I said Jerry Potter.
Okay.
I'm Jerry Potter.
You mean Perry Hodder?
Anyway, so let's look at a couple examples. Now, do you guys think these are probably going to go over the two things we just talked about?
Liz.
Probably. There's a good chance, okay? So 3x plus 2y equals 6. Y equals negative 3 halves x minus 1. Now, are these both in slope-intercept form yet? No, the bottom one is. But we need to get the top one in slope-intercept form, don't we? So I'm just going to rewrite it over here where I have some room. 3x plus 2y equals 6. And Evan is correct that we're going to subtract 3x to start. 3x minus itself is 0. 2y equals negative 3x plus 6. Nope. And then, how do we get y by itself?
Divide it by 2.
Yeah, divide every single thing by 2. Very good. 2y divided by 2 is y. Negative 3 halves x. Just negative 3 over 2x. What's 6 divided by 2, though? That one simplifies to 3. So now these are both in slope-intercept form. That's nice. So what's the m? Negative 3 over 2. Very good, Mally. What's the b? 3. We begin with b. So we're going to go up 3. Okay, then we're going to use the slope. So where am I going to go with the slope to make more points? Down 3. Very good. And then where am I going to?
Right.
To the right. Is a negative slope, because it's a negative fraction, does it look like it's going downhill?
Yeah.
Good, it should.
Well, depends on the way you look at it.
Once again, we're going to go left to right. Bless you and bless rains down in Africa, lest you forget.
I never forget, Mr. Costa.
Well, that's good. I hope that always stays true.
Mr. Costa, you do not want to smell my shoe.
I would probably agree with that statement. Okay.
Just count.
Let's look at the second equation. What's the m in the second equation?
You mom.
It is not, no.
Negative 3 over 2.
Yep. It is negative 3 over 2. You actually don't need the x, but that does tell you where the m is. Now, what's the b? -1. Now, reminder, we do begin with the b, so we're going to start with -1 down. -1, the y-axis. It's the y-intercept where it crosses the y-axis. The slope here, -3/2, so we're going to go down 1, 2, 3 to the right 2. It does look like it's going downhill.
Wait, how far down?
These lines are parallel.
They are parallel.
How cool.
Now, is there a way we could have known they were parallel before we graphed them? They have the same slope, don't they? Okay, and parallel lines should have the same slope. So, where's our solution?
None.
There is none, so it's no solution because they'd never, ever, ever touch.
No, I say so.
Correct.
That's sun.
Yes. Basically the same thing, right? No. Okay. Questions on that first one? All right, let's look at the second one, okay? Y equals 1/4 x minus 2.
Let's go.
1/2 x minus 2y equals 4. Okay. So are these both in slope-intercept form yet?
No.
The first one is, second one's not, okay? How do we get the second one?
How are you even supposed to do this? That's my question.
Okay, Phoenix?
You would rewrite it.
Okay, how do we okay, you're saying give us some room. Okay, I feel ya. Figuratively, though, because COVID.
Right.
Okay, so we rewrote it.
You would subtract the 1/2 x, and then you would rewrite. So it would be -2y equals -1/2 x plus 4.
Nailed it. So we subtract 1/2 x from both sides, and we get this now. So now we have to do one more thing to get y by itself. Phoenix, go ahead.
You have to divide everything by 2.
Yeah, divide everything by a -2. Now wait, when we divide this by -2, we create a double-decker fraction, don't we?
You need to multiply it.
So we need to multiply by something instead.
1/1.
2.
But then
By the reciprocal. So what's the reciprocal of -2?
1/2.
1 over -2. We're going to multiply absolutely everything by that. Once again, that's purely because we don't want to have that double-decker fraction. So he said multiplying by the reciprocal, it's the same thing as dividing. So when we have this -1/2 and this -2y/1, those -2's are going to reduce and you're left with just y. And that's what we want. We want y by itself. Now on that right-hand side, we have to distribute this -1/2. Can anyone tell me what -1/2 times -1/2 would be?
that's what.
+1.
+1 over
4.
4x. Now, if you need to do that off to the side, feel free. Let's look at this up here, how that would look off to the side. So you would have -1/2 x times -1/2. You multiply straight across, so -1 times -1 is +1. 2 times 2 is 4. And you solve the x, so you end up getting a +1 over 4x.
Why?
Any questions on that part before we continue? Okay, so now we have to do the 4 times the -1/2. What is 4 times -1/2? -2. And once again, if we need to do that off to the side, feel free. I'm going to do that up here to the left.
That's me.
So we could have, I'll do this in a second. All right, if you want to see that off to the side real quick, though, that 4 times the -1/2, you could have this 4 times -1/2. The 4 and the 2 reduce to 2 and 1. So 2 times -1 is -2 over 1.
He was so excited to say that.
Yes, he was.
Your stretches echoed down the hallway for like the next 10 minutes.
Probably almost that exact amount of time. So now we have y by itself here, okay? So what's the m in this equation? 1 over 4. And what's the b? -2. Now, truth be told, it actually doesn't matter which equation you graph first, because either way, you're going to graph both equations. So we're going to start at -2, then we're going to go up 1 to the right 4, and then down 1 to the left 4. And what do we notice?
It's gonna say the same thing.
They're going to be the same thing, because if we look at the other equation... Oh, okay. So if we look at the other equation, the m is also 1 over 4, and the b is also -2. We might notice we've seen these before.
Where?
Oh, in the other equation we did. And we notice they're the exact same line. So they share every single point. So where's the intersection? Everywhere. So what's our answer? IMS. Now, on the previous example, we said, well, the slopes are the same, so we can know they're parallel. but the slopes were the same here and they weren't parallel. So how can we know whether they're going to be parallel or coinciding then just from the equations? Is there something else that we could look at might help us?
Probably.
The B. These had different B's. They had different starting points with the same slope, but these had the same starting point and the same slope. So if both the starting point, the B, and the slope, the M, are the same, coinciding. If just the slopes are the same, parallel lines. Questions over that at all?
That's cool.
On this foldable, we have a couple quick instructions of how to do it. Oh, you graph each line, you figure out where they intersect. And then it has an example problem that we're going to do in the middle. Now, real quick, we're going to alter this example problem very slightly to make it work out more nicely. This first equation, y equals 2x plus 1, we're going to change that plus 1 to a minus 2. If you want to rewrite the equation, you're welcome to as well. But we're going to change it instead of y equals 2x plus 1 to y equals 2x minus 2. And once again, it's just because it's going to work out nicer.
Why is it going to work on nice with the minus 2?
Because their answer won't be a fraction. It'll just be a regular point, which will be nice.
That's pretty neat.
Yeah, it is pretty neat. Yeah.
We should have done the problems before for me. Now they're annoying.
Okay. So are these both in slope-intercept form? No. So let's make the second one in slope-intercept form real quick, okay? What do we have to do to get that in slope-intercept form? Very good. Subtract 1/2 x. I love the enthusiasm, guys. So what's 1/2 x minus itself? 0. Y equals negative 1/2 x plus 3. We want that 1/2 x first, right? Okay. So now we know our m's and our b's. So what's on the first equation? What's the m? 2 or 2 over 1. And what's the b? Negative 2. So let's go ahead and graph that, okay? So we're going to begin at negative 2. I'm ready to go up 2, right 1, down 2, left 1. And use your straight edge to continue drawing those, okay? And once again, you don't have to use a ruler as a straight edge. You can use lots of things. You can use notebook, binder, a second pencil, a phone, you name it.
Is a finger straight?
I think a finger is actually a bad idea to use as one. I don't recommend that.
Hey, I make some pretty straight turns.
Alrighty.
Gobble, gobble.
That is quite the odd flex. Now in our second equation, the m is negative 1/2, and the b is positive 3. So we're going to go up 3 because we begin with b.
Did you get from Target? Are they prescribed?
Hey, shh. Okay, so then we're going to go down 1, right 2, or up 1, left 2. Okay, so we notice we have an intersection here. And what is our intersection this time? Yeah, 2, 2, like what ballerinas wear, you know? Now on the right-hand side, it says, when should we use graphing? Okay, we actually don't know the answer to that question yet. We're gonna learn that later on. Actually, that is gonna be one of our answers. But we're gonna learn that more later on and kind of figure that out. But for now, this is what we have. Okay. Any questions on this one? Alrighty.